Hi everyone, it's Mrs. Martello. We're going to do section 3.4 and I'm on page 130. So in this section, we're going to start off by talking about horizontal and vertical lines. So I want you to write down what I wrote down here for our section 3.4 notes. When we graph a horizontal line, the equation is going to be of the form y equals a number. So there's not going to be any other variable, only a y and only a number over here. And what that means is that every single y on the graph, no matter what the x is going to be that number. So that's why it's just a horizontal line. And to graph it, you just go to that number on the y-axis because it's y equals that number. And then you just draw a horizontal line right through that point. Okay, if it's going to be a vertical line, then the equation is of the form x equals a number. So it's just x and just a number. There's no y in this equation. And this is the case if every x is that number, doesn't matter what the y is, all the x's will always be that number. So you go to that number on the x-axis and you draw a vertical line. Okay, we're going to talk about standard form in a second. Let's try out two questions here. We're going to look at example 1. So in example 1, it says graph y equals 4 for part A. So because it's y equals 4, you would go on the y-axis to 4, and it's a horizontal line right through 4. Part B, x equals -2. I would go to the x-axis at -2, and this would be a vertical line right through -2. Okay, so this means that every x would always be -2. Let's do these monitoring progress questions. So I already have my graph paper set up here. So if we're doing monitoring progress number 1, y equals -2.5. I'm going to go to the y-axis at -2.5. And because it's y equals, I'm going to cross the y-axis and I'm going to draw a horizontal line right through here. And that would be my graph, just like that. Number 2, x equals 5. I'm going to go on the x-axis to 5. 1, 2, 3, 4, 5. And this is going to be a vertical line. So I'm going to go vertically through this point and draw my line. And that's it. That's it for vertical and horizontal lines. Okay, next up is standard form. So when you have standard form of an equation, this is just a general form that we're going to recognize and look for. So the general form looks like this: ax plus by equals c, where a, b, and c are real numbers. So this is going to be a number with x plus a number with y equals a number. And that is called standard form. Okay, what we're going to do with standard form is we can find the x and y intercepts. So I'm going to write this down. To find the intercepts, first, we're going to find the x-intercept. So if we're going to find the x-intercept, think about what the intercept means. The intercept is where the point, or where the graph, I should say, crosses the axis. So I'm going to draw just a general graph here. And I'm just going to make up any old graph. Let's say it goes like this. If I want to find the x-intercept of that graph, I want to find where it crosses the x-axis right here. So that would be this point right here. This point would represent the x-intercept. Think about where this point is. If this point is on the x-axis, that means that the y coordinate must be 0. It didn't go up or down at all at this point. So for our y-intercept, we know that y has to be equal to 0 at this point. So that's what we're going to do. To find the x-intercept, we're going to plug in y equals 0. And then we're just going to solve for x. So you take 0, you plug it in for y into whatever equation they give you, and you just solve the equation for x. Let's talk now about the y-intercept. So our y-intercept is where this graph crosses the y-axis, which would be this point right here. So this would be the Y-intercept. Now think about where this point is. If it's on the y-axis, then I know that the x-coordinate of this point has to be 0. If it's on the y-axis, that means it didn't go to the right or to the left at all. So the x has to be 0, and that's how I'm going to find this number. So I'm going to plug in x equals 0, and then I'm going to solve for y. And that's how you go about doing the x and y intercepts. And then after you do that, all you have to do is graph them, and you can find what the line is going to look like. So let's take a look at an example. We're going to look at example 2. So it says use the intercepts to graph the equation 3x plus 4y equals 12. So first we're going to find the intercepts. So first, to find the x-intercept, we're going to substitute 0 for y and then solve for x. So we're going to have 3x plus 4 times 0 equals 12. Well, 4 times 0 is just going to cancel out, so you can just eliminate that term. And then if I wanted to solve for x, I would divide both sides by 3, and I can see 12 divided by 3 would give me 4. So then I can write it as a point. The x-intercept, the x is 4, and the y was 0, giving me the point 4, 0. Now let's find the y-intercept. We're going to substitute 0 in for x this time and solve for y. So 3 times 0 plus 4y equals 12. This 3 times 0 just cancels out. And now let's solve for y. I would divide both sides by 4 here, and I can see that y would equal 3. If y is 3, remember we plugged in 0 for x, that would be the ordered pair 0, 3. Now all I have to do is plot these 2 points on my coordinate plane. So here's the point 4, 0. Here's the point 0, 3. And then I just have to draw my line between those 2 points. I really only need 2 points to draw any line. So once I have these 2 points, that's all I need, and I draw my line right through here. Okay, we're going to do an example together. We're going to do monitoring progress number 4. Let's write down the equation. We have x plus 3y equals -9. Okay, it says we're going to use the intercepts to graph the linear equation. We're going to label the points to the intercepts as well. Okay, first let's find the x-intercept. To find the x-intercept, remember what we said, we're going to plug in y equals 0. Let's plug that into our equation up here, this original equation. It'll be x plus 3 times 0 equals -9. Well, 3 times 0 just cancels out, and I'm just left with x equals -9. And that's my x-intercept. So my x-intercept is x equals -9. I can write that as an ordered pair. If my y is 0 and my x is -9, then the x-intercept is the point -9, 0. So you can write it as an ordered pair as well. Okay, let's find the y-intercept. So to find the y-intercept, I'm going to plug in x equals 0. Let's plug in 0 for x into this original equation, and then we'll solve for y. So here we go. We're going to have 0 plus 3y equals -9. Well, this 0 just cancels out. Let's solve for y. So we're going to divide both sides by 3. And I get y equals -3. Let's write it as an ordered pair. So then the y-intercept, I just said my x is 0 and my y is -3. And there you have it. Now let's make our graph. So I'm going to go on to my graph paper here. This is number 4. Now my x-intercept is -9. So I could go by 1s, I could go by 3s. I can set up my graph however I want, and that's totally up to you. I think maybe for the X's, I'll go by 3's, but yeah, maybe I'll go by 3's on both of them. That makes sense. So you can set up your graph however you want, whatever you think makes sense to you. If you go by anything other than 1's, you need to label. So if my X's, I'm gonna go by 3's on everything. 3, 6, 9, this will be -3, -6, -9, and then -3, -6, -9. Okay, let's plot our points. Our first point was -9, 0. So that's gonna be all the way over here, -9, 0. Our second point is 0, -3. Let's plot that point right over here. And then all I have to do is draw my line between these 2 points here. And there we have it. There's our graph. We just graphed using the X and Y intercepts. I just made a mess, but you guys can see. Okay, good. We're gonna do one more example. Let's look at a real world problem here. We're gonna look at example 3. So in this example, it says you are planning an awards banquet for your school. You need to rent tables that seat 180 people. Tables come in 2 sizes. A small table seats 6 people, and a large table will seat 10 people. So look at how they wrote the equation. It's 6 people per small table X plus 10 people per large table Y equals a total of 180 people. Now, it was nice that they gave us this equation, but we might need to create our own equation sometimes, so be ready for that. And look at what form this is in. Do you notice that this is AX plus BY equals C? That's standard form, what we just learned in this section. So this is modeling our situation. Remember, X is the number of small tables and Y is the number of large tables. We're gonna graph the equation and interpret the intercepts, and then we'll do part B. So our first step is we need to find the X and Y intercepts. We're gonna do this together here. So we're gonna do example 3 together. I'm gonna write this down on my paper. Example 3, I would suggest you follow along with this one. Our equation was 6x plus 10y equals 180. We're gonna find the intercepts and then we'll graph it. Okay, let's do the X-intercept first. We're gonna plug in y equals 0. Let's plug that into our equation. So we're gonna have 6x plus 10 times 0 equals 180. Let's solve for x. So this just cancels out. I want to get rid of the 6 in front of the x. Let's divide both sides by 6, and I get x equals 30. If I write this as an ordered pair, my x would be 30 and my y would be 0. And that is my X-intercept. Okay, let's do our Y-intercept now. This is when we're going to plug in x equals 0. Let's plug that into our equation. We're going to have 6 times 0 plus 10y equals 180. 6 times 0 just cancels out. We're going to divide both sides by 10, and I get y equals 18. That would be my Y-intercept. I can write that as an ordered pair. My x is 0 and my y is 18. Okay, now in this question, it also says to interpret the intercepts. So that means that we want to say, what does this actually mean? What does this stand for? So just remember that in this problem, what we said from the beginning is that X is the small tables and Y is the large tables. Okay, keep that in mind. And now let's interpret, what does this mean? Well, this point 30, 0 means that we could do 30 small tables and 0 large tables. Okay, so we can have 30 small tables and 0 large tables. Okay, let's interpret the other point. 0 is our X this time, so we can have 0 small tables and we can have 18 large tables. Okay, so let's go to the question and let's see what they wrote for this one. So it says the X Intercept shows that you can rent 30 small tables when you do not rent any large tables. And the Y-Intercept shows that you can rent 18 large tables when you do not rent any small tables. So that would be a good way to write a sentence about it. Okay, let's make our graph. So I'm going to grab my graph paper here. This is example 3. Okay, so I think on this graph, I'm trying to think what I should do, what I should go by. I think I'm going to go by 2s on this graph. I think that's going to make the most sense for me. Now when I make this graph, I'm only going to do the first quadrant because there are no negative tables, so I don't need to have the other quadrants here. Remember that X is the small tables, and I'm going to go by 2s on here. So this would be 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You know what? I don't think I'm going to have enough room. I think I'm going to go by 3s instead. Let's go by 3s. I think that makes sense. So let's make this 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. There we go. Now I'll have enough room. Okay, then we're going to have our y-axis going up here. Remember, our y-axis stands for the large tables. And let's go by 3s as well. So this will be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. Okay, we're going to take our points that we found from before, our 2 intercepts. Our X-intercept is 30. Let's plot that on here. And our Y-intercept is 18. Let's plot that on here. And then we're going to connect these points. So we're just going to go from the one point to the other point. We don't want to have arrows on this graph because we can't have any negative tables. So I'm only going to connect these 2 points just like that and just show that it's only in between these 2 numbers. Again, we can't have negative points. Okay, let's go back to the question and let's see if we can finish this problem up. It says for part B, find 4 possible solutions in the context of the problem. So we actually already found 2 possible combinations. It says find 4 possible. We already found 2. Think about what we did here. Here's one possibility. Here's another possibility. So for part B, we're basically going to use this, what we just found, 30 small and 0 large. That could be one combination. We could have 0 small and 18 large. That could be another combination. And now I need 2 more. So to find 2 more, I think I'm going to look at my graph and see if I can find 2 more points on the graph here. And you can pick any 2 points that you want. Just make sure that you're picking points that look like they're working on the graph, and then we'll just check them to make sure that they actually do work. So it looks like this point could be a point on the graph. Let's just double check. 6 and 15. Does 6 and 15 work in the equation? Let's see. If I take 6, I'm going to do it down here, 6 and 15. If I plug that into my original equation up here, let's see if it makes it true. So 6 times 6 plus 10 times 15, does that equal 180? So this would be 36 plus 150. No, that doesn't equal 180. So this point would not be a good point. Maybe I need to pick a different point. So let's pick another point here. Maybe let's pick the point 10, 12. Let's look on here. Let's see if that would be a good point. So it would be 10, 12 would be this point right about here. Let's see if that point would work. 10, 12. Let's plug that into the original equation up here and let's see if it makes it true. So 6 times 10 plus 10 times 12. Let's see, does that equal 180? So this would be 60 plus 120. Yep, that would equal 180. So this one does work. So let's write that down. That means that this would be 10 small and 12 large. Okay, we're gonna pick one more combination. And again, I'm gonna look at my graph here. And you can use your graph to help you kind of figure out the points, or you can just pick numbers and try to figure it out from there. Let's see, let's try to do 26. This point looks like a good point. 26, let's see if that works. So I'm gonna take 20 and 6. Let's plug that in to our original equation. Let's see if it works. So it would be 6 times 20 plus 10 times 6 equals 180. This would be 120 plus 60. Yep, that one equals 180. So I know that this point also works, which means I can have 20 small and 6 large. And that would be another combination I could do.